Hi, everybody, and thank you so much for clicking on this video to watch Lesson 4-4 Proportional and Non-Proportional Situations. And the essential question is, how can you determine whether a real-world situation is proportional or non-proportional? Let's play the video.
Woohoo! Hodel just got her driver's license. Now, she's got a bit of a dilemma on her hands. Her parents have offered to buy her a used car that will then cost her 50 cents per mile in gas and maintenance fees. Sounds like she's getting a pretty good deal, huh? Hodel's other option is to contribute $5,000 that she has saved from her after-school job. Then, she can get a brand new hybrid car that will cost her only 10 cents per mile in gas and maintenance fees. Hodel likes to think ahead. She plans to keep the car until she graduates from college, and she intends to drive it a lot each year. So, what do you think? Which option will cost her less? In this lesson, you'll learn how to differentiate proportional situations from non-proportional ones to help her decide.
So this reminded me when we were gonna buy the cars for my kiddos. My youngest one, he wanted like an older model of the car, and then my husband's like, "Nope, I'm buying a new one if you want to." And then he got what is it, a Honda SI, and his hands were sweating when we were getting that brand new car, and he was like, "Oh, I can't believe that they got it." But that was my husband's idea. I would not buy a brand new car. But anyway.
If a relationship is nonlinear, it is non-proportional. If a relationship is linear, it may be either proportional or non-proportional. We'll find out what makes a linear relationship proportional. At Acme Hardware, 3 batteries cost $5. A 6-pack of the same batteries costs $9. A 9-pack of the same batteries costs $13. The table shows the cost of batteries at Acme Hardware. Is the relationship between the number of batteries sold and the price proportional? First, graph the points in the table to find out if the relationship is linear. Is the relationship between the points linear or nonlinear?
So we see that the points do end up on a straight line, so then that means it is linear, okay?
That's correct. The relationship is linear because a line can be drawn through the points. Now, look at the ratio of cost to batteries sold for the first ordered pair.
So for the first order pair, remember it's always the y on the top and the x on the denominator, so it's 5:3. That would be the ratio.
The ratio of the cost to the batteries sold is 5:3. Look at the next ordered pair.
The next order pair would be 9:6. So 9:6 reduces to, what is it, 3 halves, so it's not going to be proportional.
The ratio is 9:6, which is not equal to 5:3. Let's look at the last pair.
13:9, which is still not the same as any of those.
The ratio of 13:9 is not equal to any of the other ratios. The ratios of the cost to the number of batteries sold are not equal. Is this relationship proportional or non-proportional?
Since the ratios are not equal, they're not proportional. The other thing that some of you have already mentioned is, well, if I draw the line, is it going to go through the 0, 0? And it doesn't go through the 0, 0, so we know that it's not proportional.
That's correct. The relationship is non-proportional. Visualize a line through the 3 points. Does it look like the line passes through the origin?
I just answered that question. Nope, it doesn't look like it's going to go through the origin, okay?
That's correct. The line does not pass through the origin. The line does not include the origin. The relationship is linear but non-proportional.
Any questions? Email me, okay?
Let's look at the differences between proportional and non-proportional relationships. At Best Hardware, 3 batteries cost $4. A 6-pack costs $8. A 12-pack of the same batteries costs $16. Is the relationship between the number of batteries and the price proportional? The table shows the cost of batteries at Best Hardware. Graph the points in the table. Is the relationship between the points linear or nonlinear?
So it looks like the points do lie on the line, And it also looks like it goes through the 0, 0 because the slope is you go up 1, 2, 3, 4, and then you go over 3. You can also go down 4, 1, 2, 3, 4, and then over 3. Yep, and it'll go through the 0, 0. So this is a proportional. Okay, so it's linear.
That's correct. The relationship is linear because a line can be drawn through the points. Look at the ratio of cost to batteries sold.
So the first one is 4 to 3.
The ratio is 4 to 3. The next ordered pair is 6, 8.
So it's actually 8 to 6, which also reduces to 4/3.
The ratio 8 to 6 is equal to the ratio 4 to 3. The last ordered pair is 12, 16.
It's actually, well, it's the ratio would be 16 to 12, which also reduces to, if I divide both of them by 4, to 4/3, okay?
The ratio 16 to 12 is equal to the other two ratios. The ratios of the cost to the number of batteries sold are equal. Is this relationship proportional or non-proportional?
Since the ratios are equal or all equal, they are proportional.
That's correct. The relationship is proportional. Draw a line through the 3 points. Does the line pass through the origin?
Yes, it does pass through the origin, so it is proportional again.
That's correct. The line does pass through the origin. The relationship is linear, proportional, and the line includes the origin.
Any questions? Let me know.
The number of years since Keith graduated from middle school can be represented by the equation y equals a minus 14, where y is the number of years and a is his age. Is the relationship between the number of years since Keith graduated and his age proportional or non-proportional? The equation y is equal to a minus 14 is in slope-intercept form y equals mx plus b, where the horizontal variable is a instead of x. What is the value of m, the slope of the line?
Okay, so when there's no number next to the a, that means that it's going to be 1, because 1 times a is a. So that means that the slope is going to be 1 right there. Okay, 1.
That's correct. The slope of the line is 1. What is the value of the y-intercept of the line y equals a plus negative 14?
So now the number by itself, the minus 14, that's the y-intercept. So I put negative 14.
That's correct. The y-intercept is negative 14. Does the line pass through the origin?
So because the y-intercept is not 0, that means it is negative 14. So that means it doesn't pass through the origin, okay?
That's correct. The line does not pass through the origin because the y-intercept is not 0. The y-intercept is not 0, so the relationship is linear and non-proportional.
Okay, so remember it's y equals mx plus b. There's a y-intercept other than 0, so it's non-proportional.
A laser tag league has the choice of 2 arenas for a tournament. In both cases, X is the number of hours and Y is the total charge. Compare and contrast these two situations. To compare the two arenas, represent the data in similar ways. Graph the equation for arena A.
So the arena A, it's y equals 225x. So that means that the y-intercept is going to be 0. So it's going to be proportional.
The graph of arena A is a line. Find the equation for arena B.
And sorry, I didn't spend enough. So it's proportional. The y-intercept is going to be 0, and the slope is 225. So that means I go 225 up, and then I go over 1, and then right there, 225, and then I go 225 again, and then I go over 1 again. So that's the slope. For arena A, it is non-proportional because it seems like it goes through the y-axis on 3, and then it goes up all the way to 450 and then over 2. So I think they might have the same slope, right? Because they went up 425. No, 400 they went up, and over 2, nope, they don't have the same slope.
The equation for arena B is y is equal to 200x plus 50. Which of the following statements are true?
So this one is proportional, arena A, because it goes through the origin. So arena A includes the origin.
That's correct. Arena A's graph includes the origin. Arena B's graph does not include the origin. Which of the following statements are true?
So arena A is proportional because it includes the origin.
That's correct. A's charges are a proportional relationship. B's charges are not a proportional relationship. Arena A's equation has the form y equals mx plus b, where b equals 0. So, Arena A's charges are a proportional relationship. The hourly rate, $225, is greater than Arena B's, but there is no additional fee. Arena B's charges are a non-proportional relationship. Arena B has a $50 initial fee, but its hourly rate, $200, is lower.
So you have to decide which one is best for you.
Now, let's practice.
So number one, it says, how are using graphs, equations, and tables similar when distinguishing between proportional and non-proportional situations? You look to see whether the y-intercept of a linear equation is 0 to identify proportional relationships for graphs, equations, and tables. Yes, if the y-intercept is 0, then you know that it's going to be proportional. Okay, check. Well done. The next one, suppose you know the slope of a linear relationship and one of the points that its graph passes through. How can you determine if the relationship is proportional or non-proportional? You can plot the point using the slope and to find the other point and draw a line through the points to see if it passes through the origin. If it passes through, the origin is the 0, 0. So if it passes through that, it's proportional. Okay? And well done, submitted. And once again, thank you so much for watching.